ATP and NADPH. Okay, and what's the other thing that's given off in the light reactions? Oxygen. Okay, oxygen comes from the water splitting. All right, now remember when we talked about NADH versus FADH2 and where they drop electrons off in the chain in respiration, and we said NADH drops them off a little bit higher because it has like more energy than those electrons? Well, the Calvin cycle needs more ATP than it needs NADPH. Okay, so we have to somehow make more ATP than NADPH through this process. All right. Now, when I say the word cyclic, what does that mean?
Like a cycle.
Like a cycle. Good. So a cyclic means like a cycle. Okay. What I just showed you up here is non-cyclic electron flow. There's no cycle. It starts, it stops. And where are we getting the electrons from again? Water. Okay. Water gives us the electrons. How are we energizing them? The sun. Okay. This is non-cyclic. Comes in, up, down, done. Okay. However, cyclic electron flow means this. The ferredoxin does not pass the electrons over here to NAD plus reductase. What happens is the ferredoxin goes back over here and drops them off in the cytochrome complex. Okay? So the electrons come back, go up, go back over here, this way. What are we doing here? We're powering the proton pumps, so we're making ATP synthase. If we're just going in a cycle like this, are we making any NADPH?
No.
No. Okay? So there's both non-cyclic, where we're going to make both of them, and then there's cyclic, where we're only making ATP. And the reason for that is because we need more ATP for the Calvin cycle than we need NADPH. Okay? So we have cyclic flow, which is ATP only. Then we have non-cyclic flow, which is ATP and NADPH. Okay? Any questions right now? No, we're okay? All right, let me run through the overheads, make sure we covered everything, and then I'll give you a chance to copy down what's on the board if you want to. Okay? So, non-cyclic electron flow, this is the dominant one because it makes both ATP and NADPH. Cyclic, like I said, is when the ferredoxin goes back and drops it back off in the middle. So all it's doing is giving energy to the proton pumps, and it goes from there. Non-cyclic photosystem 2 absorbs light energy. They get excited. They get trapped by a primary electron acceptor. The primary electron acceptor passes down the chain, goes from photosystem 2 to photosystem 1. And again, remember they're opposite. I don't know why 2 comes first because it was discovered second, but they should have just changed the names, whatever. Okay? Electron transfer chain has 3 parts, okay? Non-cyclic phosphorylation makes, like we said, makes both. Okay? And then the electrons go to photosystem 1. Electrons get re-energized again by more light energy. They get trapped by a second electron, primary electron acceptor, that should say. It goes down a second electron transport chain, etc. Non-cyclic is when it makes both. Again, you have the proton gradient. We talked about all this with respiration already. Chemiosmosis, you know what that is. Photosystem 1 makes NADPH. Okay, cyclic, we just talked about that as well. ATP only. All right. Anybody have any questions?